Tired of walking down the stairs, a 75-kilogram engineering student designs an ingenious device for reaching the ground floor from his third-floor dorm room. A 60-kilogram block at rest on the ground is attached to a rope that passes over a pulley. The student grabs the other end of the rope and steps out of his window. He falls for 5.5 seconds before reaching the ground. We use the definition for momentum and the definition for impulse to fill out the table. We're going to say down is positive for the student, the pulley redirects the coordinate system, and up is positive for the block. The student and the block both start with a velocity of 0, end with a velocity of v2. The mass of the student is 75, the mass of the block is 60, so that gives us what we have here. We do the free body diagram for the student. We have the rope exerting a force upward on the student and the force of gravity exerting a force downward. That force is m times g, that's 735. For the block, we have tension acting upwards, and we have the force of gravity acting downwards. 60 times 9.8 gives us 588. Impulse is the net force times delta t. For the student, the net force is 735, since down is positive, minus t times 5.5. That gives us the impulse. And for the block, the impulse is t minus 588, all times 5.5. Since v2 is positive for the student and for the block, the final momentum is positive. P1 is equal to 0. We know P1 plus J12 plus P1 plus J12 is equal to P2 for the student and for the block. And since the mass of the student is greater than the mass of the block and the velocity is the same for the student and the block, I've shown that the final momentum for the student is slightly greater than the final momentum for the block. Now I use P1 plus J12 is equal to P2. I apply that to the student and to the block. I'll call this equation 1, this equation 2. If I add them together, I get this. Then I can simplify and solve for V2. I get 5.99 meters per second. Then using either equation 1 or equation 2, I find that the tension is 653.